Hello, everyone. Welcome to episode 221 of the J Situation Podcast. I'm recording this on July 23rd, 2024. How are all you doing on this wonderful day? Yeah, I hope you're doing well. Busy week for everyone, I'm sure. We're going to do our best to fully address the massive Knights Armament PRT series program that we published last week. Yeah, remember that? Yeah. So this podcast is going to cover that in its entirety. If for some reason I have to tap out, which is most certainly possible, I will do so. And then we'll just go ahead and reconvene next week. But as it stands, I plan on doing this in a straight shot, all the way through in one shot. So remember, if you need timestamps, they are in the episode description on every single provider. YouTube listeners, sometimes you guys forget that. That's okay. Don't worry, friends. You get the same episode descriptions and timestamps as everyone else. Yeah. Everyone in podcast land gets the same information. Yeah. So what we'll do, we'll hit the CRS first, then we'll hit the MCQ, and then we'll tie it all together with the competition at the end of everything on the market that's in the standard. Sound good? Okay, very good. So before we get into that, let me give you some quick information about the companies who make this podcast possible. Going to make this short today, these ads, because this is basically a member-driven article, and although some of these sponsors are also members of the cooperative, we really need to get going, and we don't have a lot of time. So this episode is brought to you by Legion Athletics. Everyone knows you got to get swole. It's extremely important to do so. You go to legionathletics.com, get all the supplements you need. And I've been lifting weights for a very long time. Chances are, if you need it, they have it. Use code word PewScience, save 20% off of your first order. If you like what you get from them and you want to keep buying stuff there, if you keep using that code PewScience, you'll save a net 10% off everything going forward forever. So using the points, you know what I mean? It's awesome. Episode's also brought to you by Top Gun Range Houston. They are back in operation after that hurricane hit Houston, which was terrible. They lost power for a long time, but Kyle and his crew are back slinging the guns, and they have a 15-lane indoor shooting range. Go check them out if you're in Houston. You can rent silencers there. So you can rent all the guns you want to shoot, but you can rent silencers as well. That's a pretty big deal. Okay, topgunrange.com. Check out their inventory. It's wild. Also, speaking of Knights Armament, what about high-end armament technology in Oklahoma? They sell very expensive things. That's right. Call Robert and his crew if you're looking to get a ridiculously esoteric and expensive apparatus for your shooting enjoyment. highendarms.com. This episode is also brought to you by Silencer Shop. Oh my goodness gracious. Largest distributor silencer in the known universe that you do your fingerprints and photos electronically. You cut down on errors, simplify your silencer purchasing process. You get a money back guarantee. It's pretty good. No transfer fees, no paperwork errors. You and your silencer with no drama, truly silencer ownership simplified. And finally, this podcast is brought to you by the PewScience Laboratory. I'm the technical director of the lab. And you know what we do in the interest of public education? We sponsor this podcast. We run a public research effort. We continue to push the silencer industry forward one test at a time. That is our mandate. That is our founding mandate. PewScience.com, the suppression rating, the silencer sound standard, the simplest, most accurate hearing safe ratings for small arms in the whole known universe. There are 7 sections, the most in-depth and accurate silencer data and analysis in the entire world. All available to the public 24/7 at PewScience.com. And if you would like to see more research from us, from PewScience, support all the public testing that we do, you can join with a membership at PewScience.com, which we would very much appreciate. That would help us keep the lights on, feed us food, and continue the work for you. Yeah, please join if you can. Help an engineer. You can donate too if you're not into recurring things. And you know what? You don't have to give money at all. You can just enjoy this and spread the word. That would help too. Okay? Like and subscribe on YouTube. Give it a good old 5-star rating on iTunes or Spotify or wherever you consume your podcasts. And we can help normalize the use of suppressed small arms. 3 main topics for you today. As I told you earlier in the introduction, the first topic is going to be Sound Signature Review 6156. Okay, that is the full study, the Knights Armament 556 QDC CRS-PRT and the 556 QDC MCQ-PRT. That's a system optimization study. Okay, that's on the SR15 Carbine Mod 2, the CQB Mod 2, the M4A1R3 Daniel Defense 14.5-inch mid-gas gun, and the Mark 18 10.3-inch carbine gas Daniel Defense gun. Those are 4 5.56 SBRs with 2 silencers with both the 3-prong and the MAMS brake. It's MAMS. That's right. It's MAMS. So this is a 16 test program. We're gonna talk about the CRS in that topic first, okay? This is the technical discussion. So you're here for the tech talk today, okay? That's what we're doing. Topic 2, it's going to be the other half of the study. We're going to go MCQ, the mini corn, okay? We're going to talk about the MCQ, the small corn. Does it give small performance? Well, yes and no. Okay, we'll have technical discussion regarding that. And then finally, in topic 3, we'll give overall comparisons. How does the Knights Armament PRT series stack up to the competition? It's very important for you to understand that if you are in the market for these type of silencers, or if you're just a silencer connoisseur and or researcher, developer, designer, and you just want to know how they work. Okay, we'll move into topic 1 at a time of 6 minutes. In 5 seconds. Okay, perfect. One moment. Did you notice I'm going through this quickly? I am. Topic 1, Article 6.156. 16 test series on Knights Armament apparatus. This is the largest individual silencer study ever published in history, and the largest Knights Armament study, I think, published in history too, regardless of any type of equipment publicly that I've seen, which is really cool. And members made it possible, so that's awesome. We're going to talk about the CRS in this topic. If you just skip to this timestamp, we're going to go through this study. This topic concerns itself with the full-size QDC CRS-PRT. Okay, and this study, boy oh boy, was this ridiculous. I already gave you the background on the program. So if you're just tuning in and this is your first time listening to this podcast, and you are wondering what the heck it's about, and how did this happen? Who made it happen? Why did it happen? That's episode 220. Okay, so that's last episode. This episode, ladies and gentlemen, is the technical discussion, so hold on to your britches. Tell your wife or husband you will catch them later, and give the kids something to do safely and buckle up, because you're going to be here in a minute. Now, let's talk about the CRS, shall we? Combat Rifle Suppressor. That's CRS. The QDC/CRS-PRT, the Quick Disconnect Combat Rifle Suppressor with Pressure Reduction Technology. That's the whole alphabet soup acronym. Ladies and gentlemen, that's the silencer. This bad boy is DMLS 3D printed Inconel. That's right. So what have we looked at lately that has been 3D printed Inconel? Man, it seems like there are a few other silencers like that lately, right? We have the 4 Monarch 762 very recently with a Surefire 5.56 RC3. That we had the old school AAC M4 2000. It had Inconel baffles, but not 3D printed. The Silencer Covelos. Ooh, that's another 3D printed Inconel model. Oh, we got the KAC WB. That was 3D printed Inconel. The KAC ODB. They have an Inconel model of that too. Yeah. So there's been a bunch, right? There's been a bunch of these 3D printed Inconel silencers. Other than that old AAC can, all of those cans are 3D printed Inconel. Very interesting. Very interesting. Why would you do something like that? Why would you use a material like Inconel? Well, if you need to maintain strength and stiffness at high temperature, that is, if you need to maintain both your yield strength and your modulus when the silencer gets very hot, Inconel could be for you. That's right. But wait, there's more. No, I'm not trying to sell you anything. I'm just telling you why the people who make the silencers may choose that material. Now, why would you 3D print it? Interesting. Well, that would be because it might be easier to create certain geometries when 3D printing instead of traditionally machining. That's one reason. There are a few reasons, but that's one. And so, it's funny. Knights Armament is no stranger to Inconel, right? So they were the first ones to put it in a mass market rifle silencer, right? I believe isn't that true for like the mass market? That's true, right? I believe that's true. In the old NT4, actually. So 3D printing is relatively new to them. What did they do in this silencer, in the CRS? What did they do? Well, they do have asymmetrical baffle mouths. Okay, yeah, you could do those with machining, though, with subtractive manufacturing. Yeah, you might say, no biggie, I say. No big deal. We could do that. We could do that as machinists. Well, but they also have some interesting annular flow geometry in there, too. And this is where I think 3D printing really shines. There's also a really cool circumferential perforated plate section in the blast chamber. It's pretty smart, too. Yeah, you could do that with subtractive manufacturing, too, but the continuity, my friends, the continuity, right? It's pretty cool. It's pretty cool in there. That's actually a key feature. You know, the annular porting in the CRS alternates. Did you know that? And everything ends up terminating at the distal end with radial vents. Yeah, it's something we've seen quite a lot of from other manufacturers in various implementations, but it looks like Knights is doing it while maintaining a lot of the previous design philosophies. You know, you look at the old NT4, you look at the previous welded non-PRT QDC model. You know, yeah, you see, we tested that too. You know, we tested both of those back in Article 78, Article 104. We've tested both those silencers. They're in the standard. It's wild. If you go to the rankings table now, actually, and if you were to do that, and you selected Knights as the manufacturer, KAC as the manufacturer in the drop-down filter, you get a ton of data points. Okay, you get a ton of data points. And that is so nuts. There now in the standard, there's 18 Knights tests in the standard. It doesn't even make sense. But, you know, here we are. We're here. How did this happen? Speaking of the rankings table, that is something that can really help you understand perspective here, guys. Looking at how the PRT series is stacking up with the old QDC and the older NT4, man, guys, it's pretty wild. But right away, what are you seeing here? What are you seeing proved out by us, by Pew Science, by the Pew Science Laboratory? You're seeing that Knights Armament was, in fact, being pretty straight with you, weren't they? Yeah, they told you in marketing material that the new QDC PRT series was maintaining much of the suppression capabilities of the older models with higher flow rate. And what does this comprehensive test program show you? What does the data and analysis indicate? Well, it indicates exactly that. Let's dig into it. It's true. It's all there. So let's go to the article. Yeah. Okay, go to pewscience.com. If you're not there already, I'm already there because, you know, I had a head start. Well, we're gonna. So this is Article 6.156, and if you're new to this podcast and you're just here from Knights Armament Land, wanting to learn stuff, that's awesome. Welcome, glad to have you. What we do on these technical deep dives is you can pull up the free version, the public version on the website. You do not have to be a member. That's fine. If you are a Pew Science member, I ask that you do pull up the member version of the review. You'll get the most out of it. Okay. Okay. So let me do something really quick. Yeah. Okay, I'm just trying to arrange my screen so I can more intelligently. One second, just bear with me for like a second here, dude. My goodness, I have so much stuff on my desk. It's nuts. Okay. Cool. So, let's go to the article. You have it pulled up now, 6.156. What we're going to do here first, I want to really keep this talk organized and flowing, and I don't want to delay. As you all know, there is a user adaptable tool present in this article, an interactive tool. We're going to skip that in this early part of the talk real quick. So what we're going to do is we're going to talk directly to the CRS. We're going to talk technically about the CRS silencer, and then we'll circle back to the overall tool. Okay, there's a method to this madness. Trust me, it'll be better this way. So in the article, scroll down past the tool. I know it's pretty. Scroll down past section 6.156.3. So past section 3 that has the 9-point summary, scroll all the way until you get to the colorful suppression rating graphics. Okay. There are 3 graphics there. Let's hit the top one. Okay. Bottom line up front, 27.3 suppression rating, 1 meter left of the end cap of the silencer at the mil standard height sensor location. Okay. 26.6 suppression rating, 6 inches right of the shooter's right ear. What does that do? That results in a 30.4 composite suppression rating on the 14.5-inch Knights Armament SR-15 carbine Mod 2 rifle. Yeah, that's right. The CRS silencer, the full-size 5.56 PRT silencer from Knights, is achieving a 30.4 composite suppression rating on that host weapon. Okay, now, is that the standard M4 mid-gas? No, it's not. Is the silencer doing better on the Knights gun than it did on the M4 mid-gas, the Daniel Defense gun? Yeah, it is. It is actually doing better on the Knights gun. And we're going to talk a little bit about why that is, but let's look at the data first. Okay, so scroll down past all the words and stuff, past the first table. You gotta scroll down, keep scrolling until you get to the first data plot. That's right. That's figure 1. Yes. You will have figure 1A and figure 1B. This is per typical blast overpressure in the free field. Okay, this is 1 meter left of the silencer's end cap at the mil standard sensor location of 1.6 meters above the ground. So what do we see here? What do we see? Well, we see fast blowdown, don't we? Yeah, I mean, relatively. We see some late time bolt carry group return to battery. Okay, fine. So far, so good. That's making sense to us from what we know about the silencer. Let's take a closer look and see what else we can see, though. Let's do that. We're seeing something very interesting in the next figure. And look at figure 1B. Okay, so you got figure 1A, which is the full-time regime of combustion and mechanical operation of the system. Then you have figure 1B, which is a zoomed-in view. In figure 1B, we're just isolating the first 2 shots in pressure space. Shot 1 and 2, what do we see? We're seeing very interesting jet coupling. Yeah, we sure are. You're getting your first coupled jet in both of the first shots, as you would totally expect from a supersonic 5.56 round through a silencer. You would expect that to happen. You know, the Mach wave from the projectile nesting with the muzzle blast shock. You know, some people don't realize that's what that is, but that's what that is. It's very common. But really soon after that, like incredibly soon after that, what do you see in both shots? Well, you see a primary jet, and that primary, it's just a lot higher in amplitude, but it has a ramped rise time, doesn't it? It's not quite a shock, is it? Not quite a shock. Interesting. And that part is actually incredibly important here, folks. You are not dealing with a secondary shock front. No, you are actually dealing with a more gradual energy release. And where do you think that's coming from? It's coming from the vents. Yes, and you can see plainly in the raw data here, it's coming out more slowly than the primary axial jetting and the bullet. So what does that mean? What does it mean? It means there's relatively significant work being done in the annulus of the silencer. At least to the point that there's enough release throttle to indicate suppression is in fact happening, right? It's real. It is functioning. You can't argue with that yet, right? You can't argue with me yet. This is all just obvious. It's maybe not obvious, but it's all just raw data. You can't, it is what it is, right? And I do want to take a moment to explain this in another way to you, if you're not catching this. Because there's some nuance here that might make you cry or not. I don't know. Remember when a very famous person in the silencer industry told you that you could get the same result as a Huxworks silencer by simply drilling more holes in the end cap of the silencer? Just drilling them around the primary bore, remember? Remember that? Pepperidge Farm remembers. I certainly remember it very vividly. And then remember how after our testing and analysis of all the Huxwork stuff, we explained to you why that statement is completely false, and that statement completely disregards physics and the actual design of silencers, like in general. Yeah. That's also the case here. Just so we're clear. Okay, now you literally have proof in figure 1b. You literally have definitive evidence disproving that statement completely. Okay, if you had simply drilled holes in the end cap of the silencer on the primary bore, you would certainly have excess jetting. Yes, you would, but it would not have that ramped rise time. It simply would not. And to claim you would have the same thing, it demonstrates a lack of understanding of shock physics blatantly. So if you want to see the PRT series do what that person said, well, you would have to make the silencer very tiny, which they did with the MCQ. And we can look at that data a little later, but I don't want to get ahead of ourselves, okay? Okay, so I just want to take that quick detour. I want to help you understand that the data we're observing from the Knights Armament CRS-PRT unit, this silencer, is in fact consistent with the silencer's design intent. It's not an accident what you see in figure 1b. That's not an accident. Okay, that is design driven. Okay? This isn't happenstance. This is how physics works, and it's purposeful. It's the math is coupled to the physical behavior. It's real. Now, let's look at how the blast propagation in the free field is manifesting globally. Okay? Let's look at the amount of blast momentum transfer potential. What is that? Well, it's another name for blast momentum transfer potential. The impulse of the wavefront. Correct. That's in figure 2. That's right, below figure 1. So in figure 2, you can see the quite incredible consistency of the CRS, actually. And sure enough, you do see the consequence of that annular circumferential jetting from the vents, don't you? Yeah, you do see that consequence. You see the rise time to peak positive phase impulse. Well, the time it takes for those curves to reach their peak in figure 2, that slope's pretty steep, right? And that is what you would expect from a silencer like this. That is what you would expect from a silencer like this. What is another word for that? The silencer has a relatively low omega metric. Yeah, that's right, low omega. Now, why is the black curve in figure 2 not falling in line with the other curves at first? Well, that's shot 1. So if you were looking closely back in figure 1b, I didn't mention something. I'm going fast, so I know it's hard to keep up, but you can pause. Go back to figure 1. I didn't tell you something, and you should have caught it if you were looking at it, but maybe you didn't. That's okay. What I didn't tell you was that although both shots 1 and 2 exhibit the same type of initial jet coupling and the same type of secondary ramped vent load, shot 1 has a little more of both, doesn't it? It has a little more secondary and tertiary jetting too. And why is that? Why does shot 1 have those phenomena occurring? Well, that's the FRP, guys. That's the FRP. That's the first round pop from the CRS. Yes. And you'll hear it when you shoot it. You will. Your buddies will as well. They will. It's there. It's real. Data says it's real. And in fact, your ears will be able to tell as well. The good thing, though, from this silencer is that ends in early time, doesn't it? The FRP. Yeah, it does. The FRP doesn't run away like a crazy person, does it? No. Remember the Surefire SOCOM 556 RC3? Yeah, I do too. We all remember it. Remember the 3-prong test we did with that on the Mark 18? Brother. Go look at article 6151. So about 5 articles ago or so, look at figure 2 in that article. That is a high flow rate silencer that not only has erratic FRP post-peak, but the other waveforms from the other shots later in the string start to climb. Why? Silencer's heating up. Can't take it. That's right. Now take a look at the Knights CRS. Not nearly the same, is it? No, it's way more consistent. That's important to note. Yeah, it's not a different weapon. I think the CRS has a little bit lower suppression rate at the muzzle than the RC3 does on the Mark 18, fine, but which one's more consistent? Which one's more predictable in this case? I can tell you the Mark 18 waveforms are pretty similar in consistency here too. If you really want to look at them for the CRS, so you're not changing a lot, guys. which silencer is going to be more consistent overall with regard to overall signature suppression, sound, flash, gassing, everything. What's more consistent? Well, that's going to be the Knights. The Knights is going to win the consistency game over the RC3 every time, regardless of mount, and that's what we're seeing happen. And really, that's a big deal because both of these silencers are high flow rate 3D printed Inconel, dedicated 556 units. The Knights silencer seems to be more efficiently engineered. That's what the data analysis is telling us right now. That is what our data and analysis is telling us. That's not based on conjecture or subjective opinion. That's essentially the hard data that we see in our testing. Now, there are erratic things that can happen with the Knights PRT series. Okay, there certainly are, but it doesn't seem really to be a problem until you get into the much smaller MCQ unit, and even then, it doesn't seem to be a problem until you use the MAMS brake with the smaller MCQ unit. Okay, so from what we're seeing, the larger CRS doesn't care much about the mount with regard to consistency as much as the MCQ will. What we're seeing with the larger CRS unit when you change the mount to the MAMS, however, is a little faster gas jetting. Okay, you seem to be getting a lower omega with that, and it happens on every single weapon you use too, which is very interesting. If you use a MAMS, it's MAMS. It's so stupid. It's great. If you use a MAMS with a CRS, you're going to get a faster rate of blast propagation out of the end of the silencer. You will. And why does that happen? Well, apparently, when you confine that muzzle blast jet from the MAMS ports, or should I say, when you confine the jet and then you jet from the MAMS ports, you're going to favor primary bore flow more than annular flow. That is what our data and analysis is showing. That is what we see happening. The MAMS can reduce FRP doing it. That's kind of cool. You know the funny thing that happens here with a smaller silencer, though? It basically becomes a wash with regard to the mount influencing gas flow. Why? Well, because the MCQ has a different internal design. We're going to hit it later, but it's so interesting how I love that we did 16 tests. And I love that we had 4 weapon systems. I love that we had both mounts because we learned so much about gas dynamics in this. And guys, I don't know if you've read this whole study. I don't know if you've swallowed all this yet, but the amount of physics in here is absolutely nuts. And the amount of things that we have just proven right are insane. This is a good time, I think, again, to speak about what's inside the silencers. It really is. So what I want you to do, hit up, and I'm gonna send you all over creation when it comes time to look in this article. Hit up research note 3 if you like. Let me do it for myself. Yeah, okay. So in research note 3, I explain in very technical language how the silencer works. So you have an early diffuser array. That's a fancy word for saying a flange with holes in it around the ID of the blast chamber, the inner diameter of the blast chamber. Okay. Now, then you have an unsymmetrical blast baffle with a bottom port to annulus. Okay. Those annular paths alternate baffle to baffle, which is super weird. And what are we doing? It's all about quenching secondary combustion until you get to the exit. And the external features that Knights has chosen to implement here at the distal end, same thing. They're basically trying to maintain very good flash performance while maintaining high flow rate. To do that, they have to get the timing right. They got to get the timing right, okay? They have to make sure that the temperature gradients don't get too extreme. That's the name of the game. Managing your temperature gradients. The exterior of the end cap, the distal end of the silencer, it's not just for show. It's not just for show, and it works very well. Okay, if you reduce the temperature gradients at shock boundaries, you physically reduce the likelihood of secondary ignition. And you're reducing the likelihood of visible flash, in plain English. There's a lot of features in the Knights cans for flash reduction. And they're doing it relatively well. Now, something in Research Note 3 that I think is important to note here is the difference between this type of technology and the flow-through technology, which is a Huxworks thing in flow silencers. Okay, in a Huxworks silencer, the annular flow paths are significantly longer. We know this. What does that do? Well, it gives more time for gas expansion, gives more time for turbulence generation, and we've explained this many times. That increases the efficiency of heat transfer. It's a double whammy for increased heat transfer efficiency. That results in higher suppression performance. It simply does. And that is why something like the Flow 762 does so well. Now, it's not all roses for the Flow series from Huxworks, right? Because for one, it's a titanium silencer, so your visual signature with centerfire rifle, it's probably gonna have some sparking. And not all titanium rifle silencers spark. That's very important to understand. But that one, we found it does. We talked about that in the past in our night shoots. The other thing you have to worry about is excess gas momentum, making things loud near reflecting surfaces if your Omega drops too much. Yeah, you got to watch that Omega. So with the full-size Flow stuff from Huxworks, it's really not as much of an issue. When you go to your Flow 556K, that can be an issue. And the previous generation HXQD stuff, definitely can be an issue. Now, with the night stuff, with the PRT, it looks like in the full-size CRS unit, the Omega's at a point that you won't have as big of a problem as some of the super fast flowing models do out there. But make no mistake, this is a low Omega silencer, and you will certainly know it when you shoot it. You can't hide physics, okay? Now, what about alpha? What about the early time shock environment inside the silencer? Yes. Well, it seems not to be super high, but not super low. You're not going Huxworks low here. You're not, but you're also not going to be like an NT4. You're venting early. So there's only one vent in the blast chamber, but it does work. And let me back up. When I say you're not going to be like an NT4, you're not going to have the back pressure of a legacy NT4. Not that had super high back pressure, but it has way more back pressure than the PRT. I'm not talking about the new generation NT4. That's a completely different animal we'll have to address later. We haven't even tested that yet, okay? So, in the PRT, you're venting. In the CRS-PRT, you're venting early. And keep in mind, I'm saying CRS-PRT. Do not think the discussion in this topic applies to the MCQ. It doesn't. It's a different silencer. You're going to have a bad time. Do not think that. We're still talking large silencer. We're talking CRS. This is topic 1. So you're venting early with the CRS. There's only one vent in the blast chamber, but it does work. And speaking of that vent, actually, and this is really cool. If you want some evidence that it's working relatively expediently in the time regime, a guy on social media sent me some wonderful temperature data he gathered, along with some photos of burn marks on his silencer. And sure enough, the area adjacent to the vent on the outside of the silencer, so that would be the underside of the silencer. If you clock your Knight's armament muzzle device with the index pin up, the bottom of the silencer will get hot faster because that's where the first vent is out of the blast chamber. Isn't that right? He told me, interestingly enough, he told me he actually clocks his muzzle device a certain way so that when his rifle's slung, he has less of a chance of that side of the silencer touching him because that's the hottest part and he doesn't want to deal with it. Ouchies. So I kind of speculated in a fun way on social media that Knights put that vent at 6 o'clock because if you are only taking a few shots and haven't heated the whole silencer up yet because of heat soak and, just the time it takes for conduction to travel through the core to the OD, you could take a few shots and the bottom would heat the fastest. So that would give you time to get covered to conceal your thermal and IR signatures. Maybe if you had like thermal camo or IR camo on for the rest of your system and yourself, maybe this would help your silencer not pop off in the visual to alert your enemy as fast. Now, I mean, is that true? Is that supposition that scenario true? Could that happen? I mean, physically, it could help, right? But whether or not Knight's meant to do it, I don't know. I wouldn't hang my hat on it. I wouldn't be like, it's like those people who say, oh, the dimples help cooling. Relax, dude. Do the calc. It doesn't. Do the calculation, guys. Don't tell me cooling. Okay. Keep in mind the silencer will heat up. Eventually, it's going to heat up. It's a race against the clock. So, Never forget that if you're trying to hide thermal signature. Now, if you're a member, remember there are shooter's ear waveforms in this article for you to take a look at. You're going to see some features there as well in that test showing you that, yes, this is a low back pressure silencer. And you know what? You can see that this host does have some back pressure, or should I say this host does have some ejection port blast signature that does matter. One thing that you need to know, and this is kind of a rub in this whole thing, that I love it and I hate it. One thing you do need to know is the Knight's 14.5-inch gun that we procured and that we used seems to be less overgassed than the Daniel Defense gun, our standard test host. And we verified this with 2 Daniel Defense guns that we have in inventory. We only had 1 Carbine Mod 2 Knight's gun. So, but at least this is what our data shows. With the Knight's host we used, and since publication, we've received some anecdotal feedback from users indicating that their Knight's Armament Carbine Mod 2, their guns are fairly overgassed. And when they say that it takes quite a lot of tuning to get them to function how they want them to function with the silencer. And we did some internet searches to see this too. We don't know why that is. But anyway, to that I say this is a low back pressure silencer, so we didn't have that issue in our program. Now I will say we have a lot of experience with the Daniel Defense gun with its 076 port at the mid length, at the standard mid length gas location. Keep in mind the Knight's gun has a proprietary port size, proprietary gas block fitting, proprietary gas port location. Okay, it's less dwell time than the Daniel gun. We don't know the port size on the Knight's gun. For us, the Daniel Defense gun had more gas impulse than the Knight's gun. We have to give this Knight's gun back to the user, so I don't know that we'll ever know what the true port size is. Unfortunately, the Knight's gas system, that proprietary, I don't know, man. It doesn't seem to leak. It uses compression fittings at a custom length. Oh, it's pretty slick, dude. It's kind of sexual when you really think about it. Now, in the program, this host, this 14.5-inch SR15 Mod 2 upper, it offered the highest performance for the CRS silencer. It's almost like they were made for each other. Yeah, weird. No, you will, however, get similar performance out of the 14.5-inch mid-gas gun from Daniel Defense. It will be very similar, just a little more overgassed. So use an H3 buffer if you're an M4 guy. Like me, I'm losing my mind with that. So I really think ever since we adopted the M4 mid-gas host, I don't know what I thought was going to happen with that gun. I think I might put an adjustable gas block on my personal one. So why don't we do that now? 1 second. Let's do that opportunity. And maybe I should timestamp this. Be like topic like 1B. How am I going to do this? Let's I want to use the interactive tool. Let's do that at a time of 38 minutes. Oh, crap. 25 seconds. Okay. I'm going to timestamp that because I want to scroll to the top of the article. And if you're just tuning in, if you hop to this timestamp, you're in the middle of a talk, but I just wanted to break this up for you. Don't think it's good. We're going to get in the habit of doing it. Scroll back up all the way to the top of the article and go to the tool. Okay, we're still talking about the CRS. The best way to start is under plot control, have a host selected. Okay, so if you're looking at this on mobile, you can do it, but desktop is recommended. You can click on host, so host is highlighted black, and what that's going to do is it's going to create a plot for each of the 4 hosts. If you select combined, it will put everything on one plot, which is completely nuts. If you select muzzle device, it will create 2 plots. Okay, one for the 3-prong, one for the MAMs. If you select silencer, it will create 2 plots, one for each of the 2 silencers. So select host, you got 4 plots now. The SR15 Carbine Mod 2, 14.5-inch gun. The SR15 CQB Mod 2, which is an 11.5-inch gun. The M4A1R3 is a 14.5-inch mid-gas, and then finally the Mark 18, which is the 10.3-inch gun with the carbine length gas system. So the next thing to select is data control. Under data control, go ahead and select the CRS silencer. Okay, and now we can just focus on that one for now. That way you only have one silencer on the board. Okay, and now finally, the last thing, you have muzzle device selection. So the 3-prong is in blue. The MAMS is in red. Let's go ahead and click on the red MAMS button to deselect the MAMS. Okay, and so now you just have the blue plots. Okay, so let's go ahead and check this out. Now you just have the blue plots. You have the 3-prong and all 4 you have 3-prong on all 4 hosts with 1 silencer, the full-size CRS. Now, you're just looking at how 1 silencer with 1 muzzle device performs on 4 different hosts. That's what you're looking at. It's cool, right? It's cool. So let's start with the carbine mod 2, the top left. What do you see? Well, really good bystander suppression. And by the way, I forgot to tell you. So the scale on the plots is normalized. So if you have a score of 1, you have the highest there was in the data set overall. If you have a score of 0, you would have or if you had a score like 0.1, you would have like the lowest of anything in the program. And that goes for every single metric. Every single metric is normalized on its own scale, 0 to 1. That way we can use the same scale, 0 to 1, for every metric. That's the strength of normalization. That's why you would do such a thing. Okay, normalization is a powerful tool. PEW Science members are no stranger to that, since we use normalization in our research supplements quite a lot, don't we? If you remember those plots of hearing damage risk potential in the frequency domain in our member research supplements, there's normalization schemes there as well. Helps you understand percentage-based performance. Same here. Okay. So again, back to the top left plot, carbine mod 2 SR15, CRS, 3-prong, really good bystander suppression, really good operator suppression, high perceived weight, the highest system length, and high gas momentum restriction. We almost have like a perfect pentagon going on here. Interesting. Huh. What does this all mean? What does this all mean? Well, it shows that the quietest configuration of the group is this. That's okay. What are some trade-offs, though? What are some trade-offs here? Well, the system is the longest possible you could build out of the group. That makes sense. A long host, long silencer, or longer silencer. Okay. It feels like it's probably the heaviest to move around. Why is that? Why is it the heaviest to move around? Why is it heavier to move around when it's the same silencer on 11.5 and 10.3? Why is it heavier to move around? Well, I mean, because the weight of the silencer is not changing. Well, it turns out the barrel being longer and the muzzle being further away from you will make the gun feel heavier. Yeah, that's because of moment. That's a quantity called moment, or you can think of it as the torque. It's a torque about the barrel extension. You have a higher torque, a higher moment. Yeah, you're literally having to resist the bending moment caused by the lump mass in the end of the barrel. Yeah, silencer users know this. The longer the barrel, all other things equal, the more handling will be influenced. Yes, and when the silencer's heavy, and this one is certainly not light, is it? It does increase that. It does increase that, okay? So what else is on here? Gas momentum restriction. Oh my goodness. That's right. The bottom right of each plot is gas momentum restriction. What is that? That's the omega. It's omega. The omega metric allows you to quantify the rate of blast momentum leaving the silencer. Yes, the blast momentum accumulation rate. We've restricted the most amount of gas momentum possible with this setup. How? We use the longest barrel, the longest silencer, and we use the Knight's Armament gas system. And it looks like this configuration has the best chance of being quiet near reflecting surfaces. Well, quietest of the group. Don't think it's quiet, but it's quietest of the group. And that can be a win. It can be a win in some cases, okay? This also has the potential for, the most potential for gas stack to occur, though, doesn't it? It does. It's a tight system. It will stack if you let it. Most things will. So what happens when we change to the Daniel Defense 14.5 from the SR15 Knight's gun? Well, some very interesting things happen here. We're losing muzzle suppression. We're losing momentum restriction. It looks like the operator suppression is suffering a little too. Is this gas leak, perhaps, because the gas system is a little sloppy on the Daniel gun? Because let's be honest, it does leak. You can see it. Is it a dwell time thing? Is it a gas port thing? I think it's probably all three together. That's what I think. I think it's a more leaky system. I think the system's more overgassed. I think it functions sooner. I think the pressure's higher in the system in early time. I just don't think it's quiet. So the data shows. I think that's what I think is happening. It's less tuned, fam. It's less tuned, son. It's not as tuned. The Knight's gun's tuned for the silencer, apparently, or at least ours. At least the one we tested is. Don't go thinking all Knight's guns are going to be like this. Apparently, that's not what people are saying. So I don't know what happened with Knight stuff. I don't know enough. So, some of you Knights experts, maybe you could reach out with different port sizes. I have no idea. I know the port size of the Daniel gun. They told me. Okay. But this is what happens when you're not as tuned in a gross sense. In a gross sense, the weight and length are the same, which is cool, but the performance in signature suppression and blast physics may be different. Okay, one moment. Get some water. I think we're making pretty good time. We're 46 minutes in. It's nuts. We have a lot to go. So what happens when you go Knight's 11.5-inch gun? Well, you get a lot louder, don't you? But you're a lot lighter and shorter. Yeah, that's cool. Makes sense. You're letting muzzle blast out way faster, though. That's a problem. What happens when you get even shorter and you go 10.3, though? Well, this is weird. At this point, you actually get a little more balanced, and you have a shorter barrel, but you have a very short dwell time. So I think those two things are fighting each other for signature balance here. And here's one really interesting thing: very high pressure into the CRS. It's doing very interesting things. It's really utilizing that annulus. Apparently, it's really wanting to ramp that delayed jetting up in proportionality. You've heard that term before, proportionality. That's the different blast momentum proportionality that occurs due to initial pressure conditions during first expansion out of uncorking. It's almost like harken back to the days of yore. Think about the Helios DTs. It's more complicated than this, but it's not unlike that in some physics. What you're seeing here with the CRS on the Mark 18, I do find that to be fascinating. It's fascinating. The Mark 18 is actually a pretty, I don't know. The CRS on the Mark 18 is a pretty slick little system, and it's really keeping it tight, thick, solid, tight. You're getting lighter. You're getting shorter. You really see something interesting here. I think you really do see a cool little Mark 18 silencer here with a CRS. It's cool. This is a cool tool, right? This interactive tool. If you're a CRS owner, you may want to use this. Now, how about this? Let's see what the MAMS does. Yeah, dude, click the red button, bro. Leave the blue there. Click the red button. Click the red button. Boom. It'll draw the curves right there. Now, you can see all the cases for the CRS. Gas momentum restriction drops in every single case. Isn't that wild? Your omega's dropping. Your omega drops every time. Every time, no matter what the weapon, it drops. Isn't that interesting? Why? What is the physical phenomena that is occurring that would display data like that? You're not expanding into your annulus fast enough, guys. That's what's happening. What is it doing? It's making the gas flow more unpredictable because you're not utilizing the silencer completely. You're throwing off your pressure balance. You're throwing off your blast propagation balance. Okay? In fact, the MAMS in this configuration with this silencer, it seems to increase the muzzle suppression in almost every case except for the Mark 18. And the operator suppression ends up suffering. These are very strange dynamics. Very strange, very unpredictable. The MAMS is very unpredictable with the silencer. It's not intended to use. The MAMS isn't designed for silencer use, is it, guys? I mean, I don't work at nights. I've never talked to the designers, but our data shows that they didn't design the MAMS for this. There's no way they did. So I know you can use the silencer on the MAMs. I'm not saying, but I'm saying it's not optimized. Okay. To be clear, I mean, the MAMs it's a pretty decent muzzle device unsuppressed, of course. That's what people love it. Kind of like a war comp. People love war comp unsuppressed, but things do change with the silencer. And you have to ask yourself the question, well, is the MAMs bad like a war comp with a silencer? Well, I mean, does it create more hazard? Well, no, not really. Not terribly more. But it can make things a little more unpredictable. I think that's a good way of thinking about this. And our data is showing that it actually may not utilize the silencer correctly. So you may not always get the most amount of suppression out of the system. That is what this is showing. And this really does speak to the complex gas dynamics in the blast chamber of these high flow rate silencers. And we talked about this. We've been here before with the RC3, guys. Okay, there's nothing new necessarily. We're just applying the lessons we already learned here to the PRT series. You already knew this. Now we're proving that it's real with other systems. Physics doesn't care about your brand. Okay? You want the gas expansion to be able to get to annular paths at a set point determined by the design. Okay? As soon as you start changing that timing with more confinement, you get unpredictable results. Okay? So that's wild, but it's true. But it's true. You can see it in the data. Isn't that cool? Walking you through 16 tests in real time? Nuts, dude. So what if we did the same exact thing for the mini silencer, for the MCQ? Why don't we do that in the next topic in a time of 51 minutes? Okay, 51 and 30 seconds. Oh my God. Okay. Oh, my pen died. Shoot. Oh, 1 second. Holy crap. 30 seconds. Oh my God. It's like you're writing with a pen, it just decides to not work anymore. That's really, really professional, Jay. Okay, very good. I don't have time to edit this thing. That's why I go fast like this. Topic 2. The other half of the Pew Science Knights Armament 556 PRT study, the mini corn. We've been talking for an hour, so if you're just tuning into this topic, know that we've spoken a lot technically so far. And I'm going to keep on trucking just like I would if you had been listening the whole time. If I lose you, you might need to back up, rewind, and listen to previous talk. So you look at this mini corn, the MCQ. Does it give small performance? Stay tuned to find out. So in the last topic, we just left off on the interactive tool in the article. We're going to come back to the tool, I promise. But for now, on this MCQ topic, what I want to start off with, I want to scroll down to section 5 of the article, 6.156.5. Okay, so scroll all the way down to section 5 of the article. They're all numbered. That's why I use numbers. Numbers are good. Okay, section 5. This is the MCQ test on the Daniel Defense M4. Okay, this just so happened to be, by a hair, the quietest MCQ test. So I wanted to give the MCQ the most credit, give the Knights guys, the Knights fans out there, the best news possible in the data, so they would be happy and not get super mad at me and come after me with pitchforks and torches like they tend to do when I tell the truth. Truth is hard when you have a high affinity for corn, and I understand your struggle. The drip is real. It is not lost on me, but also this is physics, so relax. I figured with 16 tests, guys, the Knights fans would be satisfied. And I figured, like, if I was going to do this, I had to do it like this with 16 tests. And that way they could be mad, but, like, how mad could they really be? Because I didn't just, like, make them mad once. I made them mad 16 times. So at the very least, even if you hate our laboratory, you hate our company, and you hate me and want me to die, which I know people do because I've seen them say it. At the very least, if you don't agree with anything we do, at least you know we're consistent. Okay? Because the 16 test addition to the pedigree, boy, is it consistent. Okay, so let's dig in. freaking trolls everywhere. I actually haven't heard a lot of bad stuff. I think when they saw this, they're like, oh, maybe we shouldn't have been so mean to Pew Science after all. Let's look at what makes the mini silencer tick. So up front, before we progress through the data, I do want to tell you, just in case like you're new to this, the MCQ is smaller than the CRS. Okay, it is. But it's also different. And the blast chamber itself has a different geometry. Yeah, and I think it's really important for people to understand that. It's very important for you to understand it's not just a shorter version of the CRS, guys. There's different physics going on, and the design is adapted to deal with them. Okay? You have a lot of turbulence generation potential here up front in the silencer and the MCQ. You have some really beefy reflector geometry as well, but you're not venting directly to annular space in the first chamber. You are not. And why? Why would you not need to do that? Or why would you not want to do that? Well, the silencer is super short. Okay, so you're most certainly going to run out of time when it comes to gas confinement and expansion, right? You're going to run out of time. Remember the dimension of time. We talk about the dimension of time in the silencer sound standard in this podcast all the time. It's very important for you to understand the time domain. Everything is in a continuum in the time domain. This is not static. Everything's moving. The plots you see are snapshots of glimpses of physics. Okay? So in this design, if you want to maintain flow rate, the downstream restrictions are minimal. You got a really well understood finite duration of combustion and blast propagation. You know how fast it's going to travel through the silencer. By the time you would vent to annular space, you could potentially already have significant propagation out of the primary bore at the distal end, frankly. Okay. There's a potential not to need to vent as early. And there's nothing wrong with not venting as early because of these space limitations and the time limitations. There's nothing wrong with doing that if it does what you need it to do. There's nothing wrong with pivoting in your high flow design, okay? And that is, for a lot of you, probably the $1 million question here. Does this thing do what you need it to do? Like you personally, for your systems you may be using, does it do that? I mean, does it fit your needs? And I think we have the data and analysis to help you answer that question. I really do think we have that. So let's do that. Okay, let's go back up to the top of the article. Below the user tool, I'm not going to the tool yet. We're going to go back to the tool and come down. Let's go to the rating graphics, okay, that we put there. The colorful square figures with a big suppression rating number in them. Okay, so these are the three that we chose to present in the article, the three primary graphics. And actually, each of those three have two data sets in the flash hider and the MAMS, but two of the three big squares are for the MCQ. Okay, we just got done speaking about the CRS in the last topic. For the MCQ, what you see here, there's two primary platforms we wanted to present. The M4A1R3 mid-gas with a 3-prong, 14.5-inch mid-gas, and then the Mark 18 with the MAMS. Okay, we showed the in-depth data for these two cases because the first one, it's the highest performance case for the silencer, like I said. The second one, it's the highest, shortest performance case for the silencer, and it uses the MAMS when the MAMS does some interesting stuff, and I want to show you that too. That's a really important part as well. Okay, so what we'll do, we'll go back to section 5, 156.5. Just go all the way down, scroll all the way down, scroll all the way down. Okay, section 5, and we're going to talk about what exactly the MCQ does on a 14.5-inch gun, why it does it, and how it differs from the CRS. Okay, one second. Okay, scroll down to figure 5. Yeah, figure 5. You have figure 5A, figure 5B. Again, this is blast overpressure in the free field, like you're used to seeing every article. But what you're seeing now that you didn't see with the CRS is very interesting. And folks, there are some major differences here. First of all, the overall blast pressure amplitude, I mean, you're You're pretty high here, guys. You're pretty high. And the load shape is beginning to make the peak very, very important here. Some of you physicists will understand this. You see, with many suppressed small arm weapon system signatures, peak dB is not as important. In fact, most suppressed small arm weapon systems, peak dB is of little importance. However, as your signature starts to approach an idealized shock wave, and it starts to mimic unsuppressed fire, the peak becomes more relevant. And I want to be very clear in what I'm saying. For those of you who don't have a blast physics background, I be very careful. I am not saying that the MCQ is behaving like an unsuppressed system. One second. I'm not saying that the MCQ is behaving like an unsuppressed system, or that it's as loud as an unsuppressed system. I'm not saying that. That's absolutely not the case. In fact, if you want to see raw overpressure in the free field from an unsuppressed gun, and all these hosts, or well, not these nice guns, but for our standard hosts, look in Article 6.127. Okay, in that you're going to see unsuppressed blast overpressure. It's quite a bit different than what you're seeing from the MCQ. Okay, quite a bit different. They're not the same. So now, when you look at that amplitude, in Figure 5, pay attention again to how it is manifesting. It's high and it's also decaying extremely quickly. The blowdown in 5A, it's very fast. It's so fast, in fact, that the ground reflection is very visible, and the ground reflection is actually pretty high in and of itself. It really is. Why is that? Why is the ground reflection so pronounced? Well, it's because reflected blast loads are a function of incident wave amplitude and angle of incidence. That's right. So in other words, the free field blast load magnitude directly influences the reflection factor of the blast load that comes off of the surface. Okay, as does the angle. Yeah, they're both very influential to that quantity. Okay, they're coupled phenomena. Actually, you can't take them apart. And this is one of the ways you can tell the data is real, by the amplitude and the wave shape, and by the exact moment in time it appears. Yeah, do the math. Actually, you have all the distances. You know the speed of sound of the medium, so you can do the math. You can prove yourself that this is correct. Okay, you can prove it to yourself. Now, talk about some interesting wave phenomena here. Look at 5B. Oh my goodness, this is really cool. Here's where you really get to see something special. And some folks miss the nuance here. Remember what happened with the CRS? You got some initial jetting and then some more coupling with event loads, remember? What about here with the MCQ? First round pop's giving you full coupling. Okay, fine. But look at shot 2. What do we see here with shot 2? Oh my gosh, there's a distinct first coupled jet separate from the main shock front. And what does that mean, ladies and gentlemen? What does it mean? It means there's physical gas propagation delay out of the distal end of the silencer. That alone shows you there's annular venting taking place, and it's not the same physically as the unsuppressed signature. Okay? If you only looked at peak dB, you would not understand this. This is why we have to look at the actual physics, guys. The way I described this in the article, I believe, let me scroll down, research note 8. Okay, I wrote this down for you. So if you need to read along, to pause it and read this. In research note 8, I call this silencer-like. It is silencer-like. It is not a muzzle device like a brake or a flash hider or a blast diffuser. It is not that. It is literally a silencer, I promise. And by only looking at the initial shock propagation physics, we can see that. And that alone, without even looking at the suppression rating, it should convince you. You should be able to look at Figure 5B with your background in shock dynamics and blast physics from listening to this podcast over 200 episodes. You should be able to see that and be convinced that this is a silencer and is not the same as an unsuppressed system. Okay? So the myth and rumor that's been going around that the MCQ is basically operating like an unsuppressed system, it's not true. Okay, it's not true based on the observed physics. This is open source data and open source analysis published right here in the article in Figure 5. This is as open source as you could possibly. I give you the data acquisition speed, I give you the sensor locations, I give you the apparatus, I give you the ammunition. You can recreate Figure 5 all day long and twice on Sunday if you're qualified. So anyone on the planet with enough money and time and education can prove that the rumor of the MCQ being like an unsuppressed gun is false. I just showed you how to do it because I did it right there. Okay? Now, I'm talking it up like it's a great thing. Well, it's not all roses. I'm not saying it's bad. I'm not saying it's good. But the MCQ, it's not all roses, okay? Just because I said it's better than unsuppressed doesn't mean it's super quiet, guys, okay? Let's not. I've heard some people say some things like, oh my gosh, I'm just so impressed with the MCQ. I'm like, are you now? Are you? Okay. You know, cheap date, I guess. I'm not trying to insult it, but guys, there's levels to the game. And frankly, look at the negative phase in Figure 5B. You are going for a ride on this one. You are. But hey, silencer's really tiny. Here we are. Look, I'm not making excuses for it. This is reality. It's a small silencer. But what does it do in momentum land? You know, what about impulse? Well, it shows up there. It shows up there, and it's a lot, guys. It's a lot of impulse accumulation, and it happens really fast. You are way less in peak gas momentum transfer potential amplitude, way less impulse amplitude than you would be unsuppressed. So that's good. Again, we're proving that you're still not dumping gas like you would with a bare muzzle, but you are jetting quite a bit. Now, what happens with the MAMs? I'm gonna skip. There's so much to talk about. You can read the article. It's like, oh my god, I'm dying. What happens with the MAMs? Well, much of the same. Actually, much of the same happens with the MAMs in some ways, but there is some potential for erratic behavior with the MCQ. And, you know, you got a little glimpse of that. You got a little foreshadowing into that with the larger CRS. It's just that with the MCQ, you have less room for error. Why? Well, your runway's shorter, bro. Less time. You run out of time. You run out of time. You're so small. Okay? It looks like what is happening with the MCQ on a MAMS is, remember we talked about focus jetting, preventing that early time expansion? On that first shot, you might get a runaway jet. Scroll down to this next test on the Mark 18 with the MAMS in section 6 in figure 9. Figure 9A and 9B. I made it simple for you here. Just pressure in the free field in 9A and impulse in the free field in 9A. Or 9B. I think I mislabeled them, but called them both the 9A. Typo. I'll fix it later. Does figure 9 remind you of anything? It reminds you of the behavior of the RC3, doesn't it? I think I said this publicly. I think I said in the article, the PRT series is more consistent than the RC3, for sure. But when you use the MAMS with a short MCQ, stuff like this can happen. So just be aware, okay? Research note 9 talks about this. The reason we think for that first shot erratic behavior in that one test was the perfect storm of the Mark 18 10.3-inch barrel, the MCQ small design, the MAMS influence on initial wave expansion behavior. Those are our three contributing factors to our theory of why that occurred. Now let's go back up to the tool and see what's what. Okay. I am running out of gas, but I am determined to finish this. Gosh, this is crazy. I'm so crazy for doing this. 1 second. I might have to take a break and come back. Okay. let's see. Yeah, let's go back up to the tool, scroll up to the top of the article. Now, what we're going to do, I'm going to take away the MAMs. So now I have a blue plot for 4 hosts. I'm going to select both silencers. You got both silencers on each plot, but they're only blue. Okay. Make sure both silencers are selected. What do you see happens in optimization space with the MCQ over the CRS? Okay, the MCQ does suffer in suppression over that of the CRS, doesn't it? But you're doing way better in length and weight. You're doing way better in length and weight now. You're getting way lower omega, way lower momentum restriction. So if you're really close to reflecting surfaces, just know this silencer is going to let you know. It will remind you. Now, I do find that a little interesting since it's meant for close quarters. It's ironic, but it's short. You know, and this is, if I was Knights, which I'm not, obviously, look, I'm not here to Monday morning quarterback. But if I was Knights on this one, I might have restricted flow a little more on the smaller silencer. Honestly, to me, the shooting experience is fine with the CRS flow rate. So why not go a little more restrictive on the smaller MCQ? That's like my, Monday morning quarterback gut, at the bar talking, just 2 guys talking. Okay. I mean, now to be clear, if you want to be technical about it, they did avoid venting in the first expansion chamber. Okay. But maybe there's something else they could have done. Okay. Maybe there's something else they could have done. I have some ideas, but it is what it is. The data's the data. We can't really change it. You will see that you don't have a huge difference with the MAMs on influence of momentum transfer rate on the MCQ as you do with the CRS. So let's go ahead and let's see, select only the MCQ, then click the red button, and now you have red and blue at the same time. You have both muzzle devices, but only the MCQ. When you look at this, that's a really telling graphic, these 4 plots, because what you're seeing here, you're like I said, the gas momentum transfer potential really isn't changing as much with this MCQ like it did with the CRS when you change muzzle device. And why is that? Guys, we talked about it already. This should make sense to you based on how the silencers work. You have much less potential for gas expansion to matter that much. With the smaller silencer, you don't have enough time to deal with it. You don't have that early annular space anyway. You can't access it in the first chamber. Okay? So it really doesn't matter until what? It doesn't matter until what happens. Until it gets out of control, like on the Mark 18 test. That sucks. But that's like super erratic. And that's the only time it happened in the 16 test. So it shows you the limits of the performance potentials and stability of the system. Frankly. Okay. Oh man, you know what I just realized? I didn't give the timestamp for when we looked at the tool for the MCQ. So let me make a note to myself here. And then what we'll do, we're going to look at the entire data set now in topic 3 at a time of 1 hour, 13 minutes. And 29 seconds. Okay, I'll have to go back and put that other timestamp in there for the tool. I'm noting that too. Shoot. Yeah, I'm trying, guys. It's like, it gets complicated with all these timestamps. Okay, 1 second. Topic 3, overall comparisons. Okay, so if you just tuned in to this topic 3, we've been talking for over an hour, solid, about the CRS-PRT and the MCQ-PRT. So we've talked about a lot of things, a lot of data, a lot of analysis. And now we want to talk about how the PRT series in general stacks up to the competition. Okay, and luckily this study contains that information as well. Okay, and there's a lot of ways to look at this data and analysis, guys. Remember, there are 16 tests in this study. You have options. You can jump straight into the rankings table in section 7 of the standard if you want, or you can use the article itself. Say, let's start with the article itself. Now, in section 7, that is subsection 7 of the article. In section 6.156.7, you have a bar chart in figure 11. I'm going to scroll all the way down. Okay, figure 11. You have all the configurations in the user tool. All the stuff we've been going through in this podcast with the user tool at the top of the article, the thing that's interactive for you, all of that data for suppression rating is in figure 11 in a bar chart. Okay. Since that just has the analysis from the program, we've already gone over all of that in the previous 2 topics. We're going to skip to the next section, the mid-gas, the M4 mid-gas. That comparison is section 8 of the article. That's 6.156.8. Okay, so the M4 mid-gas gun, apples to apples, all the silencers in the chart. Here you see something pretty interesting. That you got the MCQ going head-to-head with the Surefire Mini 2. And then you got the CRS going head-to-head with the RC2. It's wild. Now, the MCQ is actually able to achieve shooter zero risk that's pretty close to that of a Mini 2 on a 3-prong. And pretty close to an RC2 with a war comp. And that's nuts considering the size of this system and flow rate and blowback and all that stuff. That's crazy. Now, at the muzzle, it's quite a bit more severe than both, so don't get twisted. I've heard some people give anecdotal reports that it's like just as quiet at the muzzle as like these bigger silencers. I'm like, I don't know how that could be possibly true, but maybe you have a different silencer than I do, or some kind of crazy gun that I don't have. But I don't see that as physically possible. I mean, it's good. I mean, it's good. 8 to 12 points lower. I'm looking at the graph. I'm like, I don't understand how that could possibly be true. Maybe they think when they're shooting it, maybe they're like, I don't know what they're doing. Maybe they're just going off like shooter's ear. I don't know what impression they're getting. And no one has given me specific details. They just kind of anecdotally, oh yeah, it's the best silencer. I'm like, well, maybe for you, but it's loud. But it's good for size, and that's what it shows. And the CRS is interesting. It's really not able to match the RC2 in raw suppression, but in operator hazard reduction does come close when you compare 3-prong to 3-prong, doesn't it? Now the WB on the chart, well, that's walking all over everything. It's walking all over the night stuff, but different type of silencer. So here we are. Now, keep in mind the M4 mid-gas is a bit overgassed in our experience. It's not helping any of these silencers, that's for sure. It's not helping anybody, dude. M4 mid-gas, I know we picked it. Look, when I picked the Mark 18, at first people were mad. I'm actually super happy with the Mark 18. When we picked the M4 mid-gas from Daniel Defense, I'm less happy. I'm going to say it. Now's not the time or the place to discuss that, but it is what it is. Now, let's look at the Mark 18. Scroll down to the next section. Much larger data set. This is section 9 of the Silencer Sound Standard. This will be figure 13. How are the PRT systems stacking up here? Because remember, and what I meant to say if I didn't say it, in the M4 data, the M4 Daniel Defense gun is not helping any of these silencers. It's overgassed. It is showing how difficult it is to suppress. So in that respect, maybe it is helping us understand things. But looking at the Mark 18 data set, much larger data set, how are the PRT systems stacking up to all of these silencers? Okay, and I wrote some notes down to organize the thoughts since you could look at this all day. If you use a MAMS with an MCQ, you're holistically outperforming a Razor 762 and an energetic armament arcs on the Mark 18. And that is nuts considering the size of these 3 systems when you compare them and what they can do. And I can tell you from personal shooting experience and lab testing experience, the arcs will blind you with flash in bright sunlight. Yes, it is a white hot flash in daylight. That's how much it flashes. It is absolutely nuts. And it's not just on the first round. It's not just on the 5th round. It's not a new silencer. This is like, that's all it does is flash you. So if you want to compare like a compact light silencer that's supposedly great for its size and it's engineered to do, I don't care. The MCQ is exponentially better than that silencer in every measurable metric that you could possibly have. unless you were talking about like, oh, it's lighter. Okay, well, the MCQ is not heavy, so relax. You know what I mean? That goes back to that argument of like, oh, if we divide the weight by the mouthfeel, we get the best silencer ever. It's like, okay, well, pick a metric that matters. Stop your fantasy land. The wild part about the MCQ is how close the overall performance is when you're considering some of these larger silencers that are overboard. When you look at 762 silencers that are simply not designed for 556, the MCQ starts to approach them in gross hazard reduction. And that's very interesting. I think of any takeaway here, people should finally start to realize you can't just put a 762 silencer on a 556 gun and do great. It doesn't work like that. Even a tiny dedicated high flow silencer that's well engineered like this MCQ, even that can approach an unoptimized bad choice 762 silencer, like on the Mark 18. Okay. And when you look at the full size CRS, you know, you get away from the MCQ for a second. Look at the full size CRS. Dude, it's really interesting on the Mark 18. I mean, it looks like Knight's Armament told the truth here, doesn't it? Look at their marketing material from before this came out. It looks like the CRS is performing on par with the old NT4 and the old QDC. And you still get that more pleasant shooting experience because you get less gas in your face with a higher flow rate. And that's a really big deal. That's a really big deal, okay? That's what you're seeing here. And the $1 million question for a lot of people is, how does it compare to the RC3? I mean, it's pretty neck and neck as far as average signature reduction, but it's more consistent than the RC3. So that alone, I think it's going to make the decision for a lot of people who are trying to choose between Surefire and Knights here. I mean, the CRS-PRT performs better and the mount's better. So if you're a high-end Gucci cloner type person, whatever that means, the Knights can's looking like your Huckleberry, man. If that's your thing, right? If this is your world that you're living in with these $1,800 silencers or however much they cost, it looks like the Knights thing is the CRS can over the RC3. Better mount, better consistency. You know? I mean, you're outperforming a Nomad 30 and you look cooler. So what's not to love? I don't know. Guys, there's a lot in the article. I hope this talk did it justice. Chances are, if you have a question after this, it's in the article. And if not, just email me and I will do my best to help you with it. This took a lot of work. We're still recovering from that. I hope this serves all of you well for years to come. This is monumental. I really think it's great. I think it's a good teaching tool. I hope it's a good silencer reference for the Knight's Armament PRT series. I hope folks can look back on it, learn about some cool physics, learn about some cool products, some cool legacy comparisons to look at as well. I think you can use this to teach others. I really do want to thank all the Pew Science members again. You made all of this possible, guys. It's the largest silencer study ever published. It really is, when you consider the totality of what's in this article. And it's all thanks to your help. It really is thanks to your help, okay? So please stay safe out there, friends. Please, somebody find me a carbine mod 2. Somebody out there, if you have a 14.5-inch carbine mod 2 that's like just sitting on the shop and you're like, oh man, we haven't been able to sell this. Weird. Dude, I'll buy it. Or like, just send me one. Be cool. I'll be your best friend. I'll talk with you folks again soon. Okay, bye.